a lot of what we're showing you, the data sets are so big, and we need the data at such high temporal resolution, basically every solver time step. We can't write all the data out to disk, so basically what we do is connect to the machine upstairs and grab the data on the fly, pipe it down here to do the rendering. And that's a little more complicated than it might sound, because the calculations are parallelized and distributed over, typically several thousand nodes. And so when we send the data down here to the rendering platform, we get little pieces of the domain from all these different nodes. So we have to kind of reassemble it down here. We have to undo the parallel decomposition. But we can do that at different stages. So we either have to do that, either have to do that first for a case like this, so then we can do the particle tracing through the whole domain. Or we can take advantage of the solver's parallel decomposition, do isosurfing, scalar color mapping, and all this stuff on each piece that we get down, and then reassemble the whole thing in the frame buffer. It's a lot easier. But it all depends on what rendering technique we're doing. If we're doing techniques that kind of involve advecting particles through the whole domain, we really have to put it together. Otherwise, you kind of trace for a little bit in your little chunk, and then you'd have to hand that off to another little chunk, and so forth, and you'd go nuts. So it's easier just to put the whole thing together first.